All right, so this is kind of a second clarifier video. We did a video on similar polygons or similar either triangles, rectangles, whatever it happens to be. And so I kind of glossed over the idea of how you determine if something is similar or not. And I'm going to take some time to break down what I actually meant by that. So if it's a similar polygon, that means each side length that should correspond with each other needs to have the same ratio. Okay? So for example, in a rectangle, okay, so we'll say that the red lines here are the length, right? So the length of these two rectangles is right here. Okay, and the width will be in blue. So the width is here, 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 and here. Okay, and notice how the sides match, right? So the width of the top rectangle is 14 and 14, right? Because the sides of the rectangle match. And then the length, 10 and 10. And then same for the bottom rectangle. So what we're saying is we need to know if the side of the big rectangle, so we'll just say the width here, so the big rectangle over this, so 21 over 14, so big over small, is equal to the width, okay, of big over small, so 15 over 10, okay. And again, if it's the same, right, it would be 21 over 14, 15 over 10. So we have to determine if these are equal, okay? Now, it makes it really simple. Can I reduce 21 over 14? Well, I think 7 goes into both of those, right? So if 7 goes into 21 3 times, 7 goes into 14 2 times. Okay, for this fraction, 5 goes into both of those. 5 goes into 15 3 times. 5 goes into 10 2 times. So they are equal. Okay, so just by looking at their side lengths, again, I compared big to small, meaning the big width over the little width, so 21 over 14. If they're the same ratio, meaning 3 to 2, then they are similar. So yes, these are similar. Okay, so that's how you kind of set up this problem. Okay, again, another way you could do this problem is you could compare length and width at the same time. So you could say, oh, well, 21 to 15 should equal 14 over 10. So the length over the width for one should be the same as the length over the width for the other. Okay? So for this particular fraction, 3 goes into 21 7 times. 3 goes into 15 5 times. Okay? For this one, I know 2 goes into both. 2 goes into 14 7 times. 2 goes into 10 5 times. So no matter how you set up this proportion, it's similar. But I do want us to focus on this one right here. I always want your ratios to be compared from big to small or small to big using corresponding sides. Okay, so here's another example that we can do together. Okay, so looking at these rectangles, are these similar rectangles? Okay, so again, I'll compare the width here and the width here. And we'll do a big to small again. So 36 over 24. Okay, and then I'll do the length of this one, so it would be the big length, so 24, over 18. Okay, so I have to see if these fractions actually equal each other. Okay, let's see. If I'm reducing here, I'd reduce 36 over 24 by, let's see, 8 goes into both, 4 goes, definitely 4 goes in it. So, let's see, 4 goes in 36 9 times, 4 goes in 24 6 times, and then 3 goes into both of those. 3 goes into 9 3 times, 3 goes into 6 2 times. Okay? So then, let's talk about 24 and 18. 6 goes into both, right? 6 goes into 24 4 times, 6 goes into 18 3 times. And as you notice, does 3 over 2 equal 4 over 3? It does not. Okay? So these are not similar rectangles, okay? And you know that because see how their ratios are different? Even if I compared, okay, let's do length and width, which is the comparison of that. So 36 over 24 should equal 24 over 18, which is what we just did. Crazy, right? So no matter how you slice it, this one is not going to work out. So no, not similar. Are these ones not similar? Because you can see the ratios are different for the two shapes. Okay? So that's part one of your, just to kind of remind you, I just wanted to kind of go through it again, and we'll do more work of this in class tomorrow, okay? And then also, the second thing is, I'm going to go ahead and tell you that these next shapes are similar, okay? So we'll make the assumption that these shapes are similar, okay? And then I want you to write a ratio from large to small, meaning starting with the larger one, then going to the smaller one. Now, it makes it really simple when they already do this for you, but see how the triangles are already lined up, like this side is related to this side, and this side is related to this side, and the base of the triangle is related to this side. Okay? So what they're saying is, if I were to write, again, let's do the greens, big to small, so 35 over 14 should equal, let's compare the blues, so big to small, 40 over 16, which should equal 25 over x. We don't know what x is. Okay? So if I were to solve this proportion, again, I have 3, but that's okay. We can do one at a time. Let's start by reducing. 35 and 14, 7 goes into both. 7 goes into 35 5 times. 7 goes into 14 twice. Okay, I know 8 goes into 40 5 times. 8 goes into 16 2 times. Okay, so if I'm following my pattern, okay, 5 over 2, 5 over 2, I know that if I reduce this by 5, that I should get 5. Okay, and again, if they are similar, so this would be different if they weren't similar, but because they are similar, we know that my ratio is going to be 5 over 2, so x is going to be 2. Okay, meaning when I have 25, okay, so I know my ratio is going to be 5 over 2, and in order to find this missing side, okay, I just need to pick one of them. So let's pick 35 over 14, right? Big to small. So 35 over 14 is going to be equal to 25 over x. So now we actually need to figure out what x is. Okay. To make it easier on ourselves, let's reduce. We already know that's going to be 5 over 2. Hello. Okay. And then we can, how do we get from 5 to 25? We multiply by 5. Okay. So we got to multiply by 5 here. So 2 times 5 equals x. So that's going to be 10. 10 equals x. So the missing side of this is 10. Okay? So just to recap, if they're all similar, we know all the ratios are going to be the same. So using that scale factor, we just compare big to small. So we knew the big side of the red side that's big is 25, but the small side that's red we didn't know. So that's how I set up my proportion. All right, last one here. So again, let's find... So they are similar. So what's this number going to be here? Okay, so that number is going to be there. Now, if by knowing these are rectangles, okay, it's not going to be hard. We know that, well, duh, if they're rectangles, that means it's going to be 16. Okay, but let's go ahead and say you didn't know that. Okay, let's say you had no idea. Okay, let's say you looked at it and said, okay, well, if I had to make a ratio big to small, I know that the big length is 15 and the little length is 10. Okay, and then let's say we knew the big width was 24 and the small width was 16. Okay, so hopefully those are equal. Again, that's just to prove if they are similar or not. 5 goes into both. 5 goes into 15 3 times. 5 goes into 10 2 times. 8 goes into both. 8 goes into 24 3 times. 8 goes into 16 2 times. So they are similar. Great. So my ratio is 3 to 2. So it's 3 to 2. Okay. And if I'm trying to match this here, if this is 24, what's x going to be? Okay. So we're going to figure that out. Okay. We can cross multiply, or again, my preferred method. To get from 3 to 24, you multiply by 8. So here you would just multiply by 8. So 2 times 8 would equal x, and 2 times 8 is 16. Okay? So, most important, just to find a scale factor. Once you have a scale factor, it makes it real easy to find the missing parts, but make sure you pay attention. It will specifically ask, find the ratio from large to small or small to big. Make sure you pay attention to that. So, hopefully this helps, and hopefully you're able to do the quiz.